An engine's job is to create power. The way it does this depends on its design. Two of the most common designs are the straight engine and the V-type engine. Imagine the cylinders inside an engine. These are the tubes where pistons move up and down. In a straight engine, also called an inline engine, all the cylinders are arranged in a single neat row. Think of it like soldiers standing in a straight line. This design is simple and very common. You can find straight 4 or straight 6 engines in many everyday cars. They are known for being inherently balanced and smooth, especially the 6-cylinder versions. Now let's look at the V-type engine. This design is a bit more complex. Instead of one straight line, the cylinders are split into 2 rows, or banks. These 2 banks are angled away from each other. They meet at the bottom, at the crankshaft, forming a V shape. This is where the name comes from. You might have heard of a V6, a V8, or even a V12 engine. The number tells you how many cylinders there are in total. For example, a V8 engine has 2 banks of 4 cylinders each. This clever arrangement allows engineers to fit more cylinders into a smaller space. The fundamental difference is all about geometry. A straight engine is long and narrow. It needs a lot of space lengthways in the engine bay. A V engine, on the other hand, is shorter but wider. It's more like a block or a cube. This shape has significant implications for everything, from the car's design to how the engine performs. The angle of the V can also vary. Some engines have a narrow 60-degree V, while others might have a wider 90-degree V. Each choice affects the engine's size, balance, and characteristics in different ways. So we have 2 distinct layouts. The straight engine is a single file line of cylinders. It is simple, long, and often very smooth. The V engine is a compact 2-bank arrangement. It allows for more cylinders in a shorter block. This basic difference in shape is the starting point for all the other distinctions between them. It influences their power delivery, their efficiency, and ultimately, where they are best used. Understanding this fundamental layout is the first step to understanding why one car might have a rumbling V8 while another has a silky smooth straight 6. When we talk about an engine's performance, we often mean 2 things: power and torque. Torque is the twisting force the engine produces. It is what gets you moving from a standstill. Power, or horsepower, is how quickly the engine can do that work. It determines your top speed. Both V-type and straight engines can be designed to produce immense power and torque. However, their layouts give them certain tendencies. A V engine, because its design easily accommodates more cylinders, is often associated with higher power outputs. Think of a high-performance V8 or V12. The V engine's compact nature makes it easier to build larger displacement engines. More cylinders or bigger cylinders mean more air and fuel can be burned in each cycle. This generally leads to more torque and more horsepower. This is why you see V8 engines in muscle cars and V12 engines in supercars. They are designed to produce a huge amount of power. The crankshaft in a V engine is also shorter and more rigid than in a straight engine with the same number of cylinders. This stiffness helps it handle the high forces generated by lots of cylinders firing, making it ideal for high-power applications. Straight engines, particularly the straight 6, are famous for something else: smoothness and a broad torquey curve. The perfect primary and secondary balance of a straight 6 means it can run incredibly smoothly, without extra balancing shafts. This smoothness allows it to rev freely and deliver its torque in a very linear, predictable way. You feel a consistent pull across a wide range of engine speeds. While a straight 6 might not reach the sheer peak power of a V12, its usable torque often makes it feel very responsive and potent in everyday driving situations. So which one makes more power? The answer depends on the specific engine. However, as a general rule, the V configuration is the go-to design for achieving the absolute highest cylinder counts, and therefore, the highest peak horsepower. If you want to build a 16-cylinder engine like the one in a Bugatti, a V-shape, or in that case a W-shape, is the only practical way. But for delivering smooth, accessible torque, the straight six remains a masterpiece of engineering. The choice between them is often a trade-off between the pursuit of maximum power and the desire for refined linear delivery. Efficiency is about getting the most work out of the fuel you put in. When comparing V-type and straight engines, there is no single winner for efficiency. It depends heavily on the specific design, size, and technology used. However, we can look at the inherent characteristics of each layout. Straight engines often have a slight edge in mechanical efficiency. This is because they have a simpler design. A straight six, for example, typically has one cylinder head, two camshafts, and a simpler exhaust system compared to a V6 engine. A V6 engine needs two separate cylinder heads. It usually has four camshafts, two for each bank, and a more complicated exhaust manifold. More moving parts mean more internal friction. Friction is the enemy of efficiency, as it turns useful energy into wasted heat. Every extra bearing, gear, and seal contributes a tiny amount of drag. When you add it all up, the V engine can have slightly higher frictional losses than a straight engine of similar displacement. This means a little more fuel is used just to overcome its own internal resistance, making it theoretically less efficient. However, real-world efficiency is more complicated than just counting parts. A V engine's compact shape can lead to other advantages. Its shorter length means less surface area, which can mean less heat is lost to the engine block and cylinder head. Keeping heat inside the combustion chamber is key to thermal efficiency. So, while a V engine might have more mechanical friction, it could potentially have better thermal management. Modern technologies like cylinder deactivation, where a V8 can run on just 4 cylinders to save fuel, are also easier to implement on a V engine. Ultimately, the most efficient engine is often the smallest one that can do the job. This is why you see many modern cars using small turbocharged 3 or 4-cylinder straight engines. For a given number of cylinders like 6, the straight 6 often has a slight advantage in mechanical efficiency due to its simpler construction. But the V6's packaging advantages allow it to be fitted into a wider variety of vehicles. The efficiency winner is usually determined not by the V or I shape, but by the turbochargers, direct injection, and other advanced systems attached to it. The decision to use a V-type or a straight engine often comes down to one simple factor: space. An engine must fit inside a car, and its shape dictates what kind of car it can fit into. A straight 6 engine is very long. This makes it difficult to fit transversely or sideways in the engine bay of a front-wheel drive car, which is the most common layout for modern family cars. It is much better suited to a longitudinal or front-to-back placement, typically found in rear-wheel drive vehicles. This is why brands like BMW, famous for their rear-wheel drive cars, have a long history with the straight 6. The V engine's main advantage is its compact, block-like shape. A V6 is much shorter than a straight 6. This shortness means it can easily be mounted transversely in a front-wheel drive car, even a relatively small one. This versatility is a huge reason why the V6 became so popular. It allowed manufacturers to offer the power and smoothness of 6 cylinders in a wide range of vehicles, from family saloons to people carriers. For larger engines like a V8, the V shape is essential. A straight 8 engine would be incredibly long, creating a very long bonnet and upsetting the car's weight balance. The engine's shape also affects a car's safety and handling. A shorter engine block leaves more space at the front of the car for a crumple zone, which is crucial for absorbing impact in a crash. Furthermore, a V engine often has a lower center of gravity than a tall straight engine, which can improve the car's handling and stability around corners. These packaging and safety considerations are hugely important to car designers. They are often the deciding factor, even before performance or efficiency are discussed. An engineer's perfect engine is useless if it simply cannot fit in the car. In summary, the choice is about priorities. If a car maker is building a rear-wheel drive performance saloon and wants ultimate smoothness, a straight 6 is a fantastic option. If they need to fit six-cylinder power into a versatile front-wheel drive platform, the V6 is the obvious answer. For maximum power with many cylinders, like in a supercar or a heavy-duty lorry, the V configuration is the only practical choice. There is no single best engine layout. The V-Type and the straight engine are simply two different brilliant solutions to the complex problem of fitting the right amount of power into the right shape space.